They left no writing, no monuments, no empires carved in stone. And yet, they are still here. Not in museums, not in holy texts, but inside you, inside your cells, inside your chromosomes, quietly shaping millions of people alive today. For centuries, history tried to explain where we came from using what it could see: ruins, scrolls, languages, borders on maps. But some ancestors never appeared in those records at all. They vanished without names, without faces, without stories passed down in words. Or so we thought, because in the last few decades, a new kind of detective entered the story. One that doesn't read manuscripts or excavate temples, but reads biology itself. Geneticists, armed not with shovels, but with DNA sequencing machines, they began uncovering something deeply unsettling. A hidden layer of human history. Entire populations that history failed to notice, yet whose genetic fingerprints are everywhere. This is not a story about kings or prophets. It's a story about invisible ancestors with outsized influence. And it begins with a question that unsettled historians, theologians, and scientists alike. What if some of the most important ancestors in human history were never recorded at all? For most of the 20th century, the story of ancient peoples was told in clean, linear narratives. Civilizations rose. They fell. Others replaced them. Texts and traditions were treated as reliable witnesses to the past. But genetics doesn't care about tradition. DNA preserves information with brutal honesty. It records every migration, every mixing, every disappearance, whether history noticed or not. And when scientists began comparing genetic data across populations, they noticed something strange. Certain genetic markers appeared again and again, across vast distances and radically different cultures. These markers didn't align neatly with known historical groups. They didn't follow the borders of empires. They didn't match languages or religions. They pointed to something else. Populations that history had erased, but biology had not. To understand this, geneticists focused on two very specific inheritance paths. The first is the Y chromosome, passed almost unchanged from father to son. It acts like a biological surname, tracing direct paternal ancestry thousands of years into the past. The second is mitochondrial DNA, or mtDNA, passed from mother to child. This lineage tells a completely different story, one that often contradicts the paternal line. When researchers examined these two paths side by side, they expected them to reinforce each other. Instead, they collided. Across multiple populations, including Jewish communities scattered across Europe, North Africa, the Middle East, and beyond, the paternal line told a remarkably consistent story. Y chromosome data traced back to the Eastern Mediterranean and the Levant, roughly 3,000 years ago. The signal was clear. Despite centuries of exile and migration, many male lineages pointed to the same ancestral homeland. History and biology seemed to agree. But then scientists examined the maternal line, and everything broke. Mitochondrial DNA told a very different story, especially among Ashkenazi Jews. Instead of pointing back to the Middle East, many maternal lineages traced to southern Europe, Italy, Greece, the Balkans. Women whose descendants would one day identify as Jewish, but who were not genetically Middle Eastern at all. This wasn't a minor anomaly. It was a structural contradiction. How could a population maintain a strong paternal genetic connection to the Levant, while its maternal ancestry came from somewhere else entirely? History had no clear answer. Genetics did. What the data revealed was not a single origin story, but a mosaic. A slow process of migration, adaptation, and integration. Middle Eastern men moving into new regions. Local women joining emerging communities. Children inheriting both identities, cultural and biological. The ancestors' history forgot were not conquerors. They were not rulers. They were absorbed. And absorption leaves a genetic signature. The deeper scientists looked, the stranger it became. Jewish populations shared genetic overlap, not only with one another, but also with neighboring ancient peoples, Canaanites, Phoenicians, early Arab tribes. Groups once thought separate now appeared biologically intertwined. The boundaries history drew were far cleaner than reality ever was. Empires rose and fell: Assyrians, Babylonians, Romans, violently displacing populations, scattering them across continents. But even in exile, genetic continuity persisted, not as purity, but as persistence. DNA showed that identity survived not by isolation, but by flexibility. And this pattern wasn't unique. Across the globe, researchers began identifying similar invisible populations, ancestral groups that contributed disproportionately to modern gene pools, despite leaving little or no historical footprint. They weren't dominant because they ruled. They were dominant because they endured. This discovery forced scientists to reconsider a foundational assumption, that historical visibility equals importance. It doesn't. Some populations shaped the future not through monuments, but through reproduction, not through power, but through survival across generations. They don't leave stories behind. They leave descendants. And every time you take a DNA test, every time a genome is sequenced, those invisible ancestors speak again, quietly correcting the record. This raises a disturbing thought. If so much of our ancestry comes from people history couldn't explain, what else are we missing? What other populations shaped us, then disappeared from memory? And what does it mean to inherit an identity built from both presence and absence? To answer that, we have to go deeper into the genetic investigation itself, into how migration, intermarriage, and isolation amplified the influence of these unseen ancestors. Because in some cases, a small group didn't just survive, it multiplied, leaving a genetic echo far louder than history ever imagined. To uncover ancestors' history could not explain, scientists had to abandon traditional timelines and turn instead to inheritance itself. Not myths, not chronicles, but molecules. Because DNA doesn't tell stories the way humans do. It doesn't simplify. It doesn't smooth contradictions. It preserves them. And the first major clue came from understanding that not all ancestry is inherited the same way. Geneticists realized early on that if they wanted to trace deep population history, they had to separate how fathers pass on ancestry from how mothers do. The Y chromosome is passed almost unchanged from father to son. It mutates slowly, predictably, acting like a biological timestamp. When two men share a similar Y chromosome, they share a paternal ancestor, sometimes thousands of years in the past. When researchers mapped Y chromosome data across Jewish communities worldwide, a striking pattern emerged. Men from Ashkenazi communities in Europe, Sephardic groups in North Africa and Spain, and Mizrahi populations in the Middle East all shared closely related paternal lineages. Despite centuries, sometimes millennia, of separation, exile, and migration, these paternal lines pointed back to the same region, the Levant, modern Israel, Jordan, Lebanon. Roughly 3,000 years ago, history had long debated whether Jewish identity survived primarily through religion, culture, or conversion. But the Y chromosome suggested something far more concrete, a shared biological ancestry that predated exile itself. For the first time, DNA provided independent confirmation that ancient Levantine populations left a lasting paternal imprint across the Jewish diaspora. But this was only half the picture, and the second half would disrupt everything. Mitochondrial DNA, empty DNA, follows a different rule. It is passed from mother to child, generation after generation, unaffected by paternal lineage. If a population developed in isolation, paternal and maternal lineages should broadly align. They didn't. When scientists examined mDNA among Ashkenazi Jews, they expected to find Middle Eastern maternal origins matching the paternal line. Instead, they found Europe, Southern Europe, Italy, Greece. In some studies, up to 40% of Ashkenazi maternal lineages traced back to just a handful of European women living around 1,000 years ago. Women who were not genetically Levantine. Women who did not come from ancient Israel. Women history never mentioned. This wasn't an error. It was a pattern. The implications were profound. It suggested that as Jewish men migrated into Europe, often through trade, displacement, or forced exile, they formed communities not by remaining genetically isolated, but by integrating local women. These women adopted Jewish identity, culture, and religion. Their children inherited Middle Eastern paternal DNA and European maternal DNA. Over generations, this process repeated. The result was a population that was culturally unified, but genetically layered. Identity passed through tradition. Biology recorded mixture. History, focused on texts and elites, never noticed the women who made this possible. But genetics did. This same pattern appeared again when scientists expanded their comparisons beyond Jewish populations. Genetic overlap emerged between Jewish groups and neighboring ancient peoples, Canaanites, Phoenicians, and early Arab tribes. These weren't distant similarities. They were statistically significant. The implication was unavoidable. Ancient populations of the Levant were not cleanly separated ethnic units. They were interconnected networks, trading, intermarrying, merging, fragmenting. The Bible describes tribes. Empires drew borders. DNA shows continuity beneath both. Some of the people who contributed to modern Jewish genetics were not Jewish in the later religious sense at all. They were local Levantine populations absorbed into evolving identities over time. Once again, invisible ancestors. Then came the violence, the Assyrian conquests, the Babylonian exile, the Roman destruction of Jerusalem. Each event scattered populations across continents. Families were uprooted, communities fractured, identities tested. From a historical perspective, these moments look like breaks. From a genetic perspective, they were multipliers. Small founding populations carried specific genetic variants into new regions. Through isolation, endogamy, and survival under pressure, those variants became amplified. This is how invisible ancestors gain outsized influence. Not because they were numerous, but because their descendants endured. This process is known as the founder effect. When a small group establishes a new population, its genetic traits disproportionately shape future generations. Over time, rare variants can become common, not through selection, but through circumstance. Among Ashkenazi Jews, this effect was dramatic. A limited number of founding maternal lineages expanded rapidly within relatively isolated communities. This explains not only genetic continuity, but also the higher prevalence of certain inherited conditions. Diseases that once puzzled doctors became understandable through population genetics. Ironically, the same isolation that amplified risk also made these communities invaluable to modern medicine. Genetic consistency allowed researchers to identify disease-linked mutations faster than in more genetically mixed populations. Suffering became data. Isolation became insight. Once again, history recorded tragedy. DNA recorded consequence. What emerged from this investigation was not a clean origin story, but a layered one. A population shaped by migration rather than permanence, by absorption rather than purity, by memory rather than geography. The ancestors history couldn't explain were not outsiders to the story. They were the story. They were the women who joined migrating communities, the local populations absorbed without acknowledgement, the small groups whose genes multiplied across centuries. They didn't leave monuments. They left patterns. And this realization forces a deeper question. If so much ancestry comes from people who were never named, never recorded, never remembered, then how much of who we are comes from lives history chose to ignore? To answer that, we need to look closer at one population where this genetic process became extreme and deeply consequential. A community where a handful of ancestors shaped millions. By the time geneticists fully understood what they were seeing, one population stood out as a living laboratory of invisible ancestry. Ashkenazi Jews. Not because they were ancient, not because they were isolated forever, but because, at a critical moment in history, very few ancestors became the foundation for millions of descendants. And DNA remembers exactly how. Around 1,000 years ago, small Jewish communities were scattered across Central and Eastern Europe. These were not vast populations. They were tight networks of families, often living under legal restrictions, cultural pressure, and periodic violence. From the outside, history describes them through religion, persecution, and language. From the inside, genetics tells a more precise story. A remarkably small number of founding ancestors, especially women, contributed a disproportionate share of the genetic material found in Ashkenazi Jews today. In some analyses, for maternal lineages account for nearly half of the Ashkenazi mitochondrial DNA pool. For women, no names, no records, no monuments. Yet their genetic legacy persists in millions of people alive today. This is the founder effect in its purest form. When populations are small and relatively isolated, chance becomes powerful. Who survives matters more than who dominates. Who reproduces matters more than who rules. As Ashkenazi communities expanded in medieval Europe, they did so from a narrow genetic base. Marriages occurred largely within the community. External mixing was limited, not always by choice, but by law and circumstance. Over generations, this created a population that was genetically cohesive, but not genetically simple. The paternal line remained strongly connected to the Middle East. The maternal line reflected European origins, and together, they formed a unique genetic structure found nowhere else. But this structure had consequences. Certain genetic mutations, rare elsewhere, became common within Ashkenazi populations. Conditions like Tay-Sachs disease, familial dysautonomia, and BRCA-related cancers appeared at rates far higher than in surrounding populations. For centuries, these illnesses were unexplained tragedies. Families suffered without understanding why certain conditions kept returning. It wasn't punishment. It wasn't fate. It was mathematics. A small founding population, limited genetic diversity, random mutations amplified over time. The same process that preserved identity also magnified vulnerability. Yet here lies the paradox. The very genetic isolation that caused suffering also enabled discovery. Because Ashkenazi communities were genetically well characterized, scientists could more easily identify disease-linked mutations, patterns that would remain invisible in larger, more mixed populations became clear. Entire fields of medical genetics advanced faster because of this clarity. Screening programs emerged. Preventive medicine improved. Lives were saved. Invisible ancestors had shaped not only a people, but modern medicine itself. And the parallels went even deeper. Ashkenazi culture preserved a linguistic artifact that mirrored its genetic structure, Yiddish, a language built from layers, Germanic grammar, Hebrew and Aramaic religious vocabulary, Slavic influences woven in over centuries. Yiddish wasn't pure. It was adaptive, just like the DNA. Language and genetics told the same story, using different alphabets. Identity survives through synthesis, not isolation. This realization forced scholars to rethink long-standing assumptions. For decades, debates raged over whether Jewish continuity was biological or cultural. Genetics showed that the question itself was flawed. It was both. Biology preserved lineage. Culture preserved meaning. And invisible ancestors, especially women, acted as bridges between the two. They weren't footnotes. They were foundations. But Ashkenazi Jews were not the only example. Once scientists recognized the pattern, they began finding it elsewhere. Populations shaped by migration, bottlenecks, and survival, not dominance, appeared again and again in genetic data. Small groups leaving large echoes. History records armies and empires. DNA records parents and children. The difference matters. This forces an uncomfortable realization. If millions of people today carry the genetic legacy of a handful of medieval ancestors, then our sense of scale is wrong. Human history is not driven only by massive populations and dramatic conquests. It is shaped just as much by quiet continuity, by families who endured long enough to pass themselves forward. The ancestors' history couldn't explain weren't powerful. They were persistent. And yet, this story still isn't complete. Because some Jewish communities don't fit this genetic pattern at all. Their DNA looks local. Their ancestry appears regional. And yet, their identity remained unmistakably Jewish. To understand why, we have to move beyond genetics alone. We have to confront the limits of DNA and the power of memory. Up to this point, genetics has acted like a spotlight, revealing hidden ancestors, forgotten migrations, and invisible populations that shape millions of lives. But every spotlight has an edge. And when scientists widen their view, they encounter communities that didn't fit the pattern at all. Groups whose DNA told a local story, even as their identity told a Jewish one. This is where the limits of genetics became impossible to ignore. Take the community known as Beta Israel, the Jewish population of Ethiopia. For generations, their origins were debated. Some traditions trace their ancestry to ancient Israel. Others dismiss them as converts who adopted Jewish practices independently. Genetics seemed poised to settle the argument, but when DNA was analyzed, the results complicated everything. Most genetic markers among Beta Israel aligned closely with surrounding Ethiopian populations. There was little evidence of large-scale Levantine ancestry comparable to Ashkenazi or Sephardic Jews. By genetic standards alone, they appeared local, and yet their religious practices, laws, rituals, and collective memory were unmistakably Jewish, preserved over centuries of isolation. No synagogues connected them to Europe. No shared language like Yiddish. No continuous contact with the broader Jewish world. Still, the identity endured. A similar pattern appeared thousands of kilometers away, in Kaifeng, China. Historical records confirm the existence of a Jewish community there as early as the medieval period. They built synagogues, followed dietary laws, and passed down Hebrew texts. But genetic analysis showed extensive local admixture. Over time, biological links to the Middle East became diluted, nearly indistinguishable from surrounding Chinese populations. Once again, DNA and identity diverged. If ancestry alone defined belonging, these communities would vanish from the story. They didn't. These cases forced scholars to confront an uncomfortable truth. Genetics can tell us where people came from, but not who they chose to be. DNA records inheritance. Identity records commitment, and the two do not always align. This realization reframes everything we've seen so far. Ashkenazi Jews demonstrate how a small number of ancestors can shape millions through biology. Ethiopian and Chinese Jewish communities demonstrate how identity can persist even when biology fades. One is continuity through genes. The other is continuity through memory. Both are real. Both are human. This is why the question, who is genetically Jewish, was always the wrong question. The deeper truth is more complex and more revealing. Jewish history, like human history itself, is not a straight line of blood. It is a braided structure of ancestry, belief, trauma, survival, and return. Some ancestors shape populations biologically. Others shape them culturally. Many did both, without ever being named. The ancestors history couldn't explain were not anomalies. They were evidence of how history itself is incomplete. Written history favors the visible: kings, wars, cities, texts. But most human influence happens far below that level. In families, in marriages, in children raised inside stories larger than themselves. Genetics expose this hidden layer not to replace history, but to correct it. And what emerges is not a contradiction, but a reconciliation. The Jewish people are neither purely genetic nor purely cultural. They are a genetic mosaic bound together by shared memory. Exile scattered biology. Tradition preserved meaning. Return, again and again, reconnected both. This is why Jewish identity survived displacement that erased countless other ancient peoples. Not because it was pure, but because it was adaptable. Zoom out far enough, and this story stops being only about Jews. It becomes a story about all of us. Every human population carries invisible ancestors, people who left no records but shaped futures through reproduction, care, and survival. Your DNA contains strangers history never named. Your identity contains stories biology cannot measure, and neither is complete without the other. So when we ask where we come from, we should be careful. History will give us dates. Genetics will give us probabilities. But belonging, real belonging, is something else entirely. It is inherited, yes, but it is also chosen. The ancestors history couldn't explain were never meant to be explained by history alone. They were meant to be discovered quietly inside us, in the chromosomes we carry, in the memories we protect, and in the identities that survived when everything else was lost.